Hello everyone. So today we will learn about bit mask plus prefixum or subarraysum using map. Okay, bit mask added to any of such subtopics will create a greater impact of this, and it will be basically asked in some uh, actually very good tech companies, MNC companies, either in the coding rounds or in the second or third level of your interviews. Okay, if you have passed one or two levels of your interviews, it will be basically asked at higher levels of interviews because this is considered as actually a hard topic. Means it's literally something more than medium level. Okay, so bit mask itself creates a greater impact to your question. Now, when it is used, it will be mainly used when some condition is given which you can create a mask of it. Okay, now what do I mean by mask? So let's say you are given um, that you want for 26 characters. Okay, for 26 characters of alphabets, you want you want every character to be coming odd times or even times. Okay, then this 26 characters could be represented in a bit format. Okay, you can represent this. Anything under 32 you can represent under the bit format. So this 26 you can represent in the under the bit format, and you can create a mask of it. So either you can store set bit for odd frequency or set bit for the even frequency, and vice versa. Clear? Another simple example, let's say this is the array 3, 4, 5, 6, 7, and I want to make different subsets of it. So what could be different subsets? Starting from empty, only 3, only 4, single, 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 all, and then double, 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 let's say 3, 4, and then all. Okay, 4, 5, 6, and all. Okay, or 3, 6, 7. This could also be one of the subset of it. Clear? 3, 6, 7. This is not subarrays. I'm telling subsets. So this could skip in between elements also. So total how many combinations we can make? There could be any combinations between 5 indexes. Okay, so this I can take either 3 or not take. I'll take 4 or not take. So this is the condition of taking it or not taking it. Either 0 or 1. I can take it or not take it. So if at all I'm taking it, I'm making it as 1. If at all I'm not taking it, I'm making it as the 0. Okay, so if everything I'm not taking any of this could be 0. If I'm taking only 3, then this could be it. Or 0th index would be 1. So 0th index would be this. Okay, and then if at all I'm taking only 4, then this could it, because in bit it will start from right side, as I've already mentioned. Okay, for 4, 5, 6, it would be this 3 digits to be 1. Okay, this 3 digits to be 1. First index, second index, and third index. First index, second index, and third index. This 3. For 3, 6, 7, it will be 0th index, and then 0th index and 4th, 5th index. So it will be like this: 0th index and then 4th, 5th index. So these are the total combinations, 0 to 2 raised to 5 minus 1 I can make out of it. So without going in deep of it, I I just hope that you are clear with what is mask. Okay. So now in map, what we will store this mask, which is some number, okay, formatted in this bit format and whatever number we have got, and either the count or mask and index based on the question asked, based on frequency or minimum maximum length. Without wasting time, let's just go to the first question. Okay, so now it's given the string s and we have to return the size of the longest substring, means maximum length of the substring. Substring is same as subarray in arrays. Okay, a continuous set of string from some L index to some R index. Okay, such that each vowel comes in even number of times. Each vowel comes in even number of times. That is, in that substring, all your vowels should come an even number of times: A, E, I, O, and U. Okay, so what we can do, as we have discussed here, we could have the bit mask related to this indices. Here it is for 0 first, means related to 5 index, we have this 5 size bit mask. Okay, but here the size of string could last until 10 raised to 5. Now we cannot make 10 raised to 5 size of bit mask. It should be maximum of 32 bits only. Okay, what is another thing we can do? We have to play between vowels. We have to check for vowels only, that the number of times it is appearing should be even. So either two case, here also two case have that the the digit should come or not come, 0 or 1. So we have got that we can use mask here. Here also we have to play between for 5 numbers only, for 5 vowels only. So we could make a mask of this 5 vowels. Okay, and that too whether it is coming even number of times or odd number of times. So even or odd, it's again playing between 0 and 1 kind of thing. Okay, okay, fine. Let's say we are taking this thing, this from L to R. Okay, this first index to this 13th index. Okay, where E is coming 2 times, and then I is also coming 2 times, and O is also coming 2 times. Now for mapping we can already do A is mapped to O. We can store this somewhere, that E is 1, I is 2, because we cannot play for A, I, O, U. We need some numbers which is representing those. Okay, let's say O represents 3 and U is 4. Okay, so now we have stored this. And what we can do, we can either make the mask where we can set bit if frequency of vowel is odd. Okay, or we can do vice versa also. But setting for the bit, okay, for this question let me do it for odd. You can also do for the even, that if at all the frequency is coming even, then you are setting the bit. That could also be okay. But if I'm going with setting of frequency, making the set bit if frequency of that vowel is odd. So let's say here A is coming 0 times. So I'm not setting it. E is coming 2 times. So it should also be 0. I is also coming 2 times. So it should also be 0. O is also coming 2 times. So it should also be 0. And U is also 0. So for this to this, for 1 index to 13 index, it will be whole 0, 0, 0, 0. This is the mask, which is nothing but 0. All zeros means. Okay. Now consider this case. Consider this, wherein you are starting from this E, okay, and you are going till this R. So you are going from 0 to 13. Okay, so everything is same, just your E changed to 3, I remained to 2, and O remained 2 only. Fine. So then your mask will be A will be 0, I will be 0. Sorry, E will be 1, I will be 0, O will be 0, U will be 0 from right side. Okay, so this is what your mask became. So this is 1. Oh, not 1, this is 2 in numeric form. Okay, so this is what your mask has become. Now we have two things, as you know. We have two things to store. One is what? One is 0 to uh, one is 0 to ith subarray. So for 0 to ith subarray, what we can check? If at all we got 0, 0, 0, all zeros, then only it's valid. Okay, and that means all 5 vowels have even frequency. And for L to R subarray, L to R subarray. Okay, so here for 0 to 13, what you have got? For 0 to 13, you have got this thing 0, 0, 0, 1, 0. Now consider only for E index, for 0th index only. For 0th index only, what mask you will get? For 0th index. So from 0 to 0 only. It's E 1 times and all rest are 0. It's only E, right? So your mask will again be what? The same only. The same mask, because all other are coming even times, only E is coming odd time. So for L to R index, what you have found? L to R index, okay, if at R index your mask is this thing, then uh, for 0 to L minus 1 index also, your mask should be this thing, should be same. What does this mean? This means that if at ith index it is even, then previously also it should be even, then it will be even for L to R. And now it has come odd, then previously also while subtracting that should be odd, and odd minus odd will also be odd, even. So for 0 to 13th index, we have got E 3 times, and for 0 to 0 index, we have got E 1 times. So if we remove that subpart, that 0th index only, we'll remove one E. So our E has become even now. So, but our mask does not represent count. It just represents whether that bit has came odd times or even times. So it should be same. So while checking for L to R, we have to check that in the map, that same mask should be present. If the same mask is present, we will take that index and we'll subtract it from the current index, as we are doing I minus MP of mask. Okay, but that same mask should be present. This is the logic of it. Okay, without wasting time, let's just code it. Okay, so we'll have one map here to uh, map this character with integer of vowels. Okay, so A is mapped to 0, E to 1, I to 2, O to 3, and U to 4. Okay, this we have already given. Now let's say you are given int 10 is equal to s dot size. We will have this map which will be storing what? Mask and I over here, index. Okay, we will have one answer also to store it. We will go. Also, we need to store the frequency of each character, how many times it is coming. So there are just 5 characters. So I'll make one frequency array of 5. Okay, initially frequency of every vowel is 0. I'll just check if vowels dot find s of I not equal to vowels dot end. This means if s of I is vowel. Okay, if I get to this, it is A, E, I, or U, then I'll increase its frequency by 1. So I'll increase its frequency of what? Vowels of S of I. This means if it is A, I'll increase 0th index. If it is E, I'll increase 1 and so on. Now we will create one mask. And what we can do? We can go to this loop of 5. We will check if frequency of J modulo 2 is not equal to 0. That means frequency of some vowel, either 0th index, first index, whatever. So it is coming odd times. Then what we can do, we can set the mask. So for setting the bit, we have already learned in the previous video. We have to set, if we have to set jth bit, we have to do it or one left shift j. So we'll set jth bit if it is odd, if it is odd. Clear? And now every time what we can do, we can check for 0 to I array, to it should be 0 0 only. For 0 to ith sub array, it should be 0 0 0 only. Okay, so we will check if mask is equal to 0. This means we have got the subarray from 0 to I. So it should be maximum of answer comma I plus 1. And for L to R subarray, what we have found just now, that the same mask should be present somewhere from 0 to L minus 1th index. So we can subtract those odd frequencies and we can get it. So we'll just check if map dot find the same mask somewhere, then we will maximize, and that index we will minus map of mask index. Okay, now if map dot find mask is equal to map dot end, that means if I have not yet found, then only I'll store, because I have to do maximum, then only I'll store, otherwise I'll not. Okay, then only I'll store the index of it. Fine, I think we are good with it. Fine, let's just submit it and check. So we are good with it. Now we'll move on to another question. It's little bit typical than this. Okay, let's just go. So this is another question wherein you are given a string S, and an awesome substring is a non-empty substring of S, so that we can make any number of swaps in order to make it a palindrome. Okay, we have to find a substring such that we can make any number of swaps in order to make it a palindrome. and we have to return length of such maximum length of such awesome substring. Okay, same as above, maximum length. Here also the s length could go until 10 raised to 5. So same, we cannot make the bit mask related to sizes. Okay, but s contains only digits from 0 to 9. So there are only 10 such digits which s will contain. So can we make the bit mask of that? Let's see the condition, whether it is take not take type or not. So it is that we have to make it palindrome. Now what is the condition to make it palindrome? What is the condition to make it a palindrome? Either all numbers should come even number of times, or any one number could come odd number of times. Okay, so this could be 1 1 2 2 2 2 1 1. So four ones, four twos. This is one of the string, or it could be like two ones, two twos, and three threes. So only three is three times. So this three and this three is palindrome, and between three is okay. So this is odd length palindrome wherein a middle number can come one time. That's fine. So it can be like the frequency of all numbers should be either frequency of every number is even, or frequency of one such number can be odd. Maximum one number can be possible with odd frequency. Okay, fine. So for even though we know we have done for the above case, okay, here we have 5 only, the bit mask of 5. Here is bit our bit mask would contain of 10 digits, right? 0 1 2 3 5 4 0 1 2 3 4 5 6 7 8 9, whatever is the digit, that index we can make. Okay, that index we can make it as 1 or 0 or something like that. Okay, fine. So let's say here, if I take this now, it's written clearly that we can swap it. It should not be like 3 2 4 2 4. This is not a palindrome. 3 2 4 2 4 is not, but we can swap. So by swapping I can make it 2 4 3 2 4, or I can make it 4 2 3 4 2. Okay, anything I can make which is palindrome. This is palindrome. Why? Because 2 frequency is coming 2 times, 4 frequency is coming 2 times, only 3 is such that its frequency is odd, which is coming just one time. Okay, so I can make 4 frequency which is coming even, so it's fine. So only 3 is frequency which is coming. So 0 10 9 8 7 6 5 4, 3 is only 1 2 1 0. So this is how our bit mask representation will come. Whatever is odd we will make it as 1. The same concept as above. Whatever is odd we will set ith bit if ith number's frequency is odd. Simple. But there it's like fully even. Okay, so for fully even we know, I mean for 0 to I subarray, what could be possible that for 0 to I subarray, mask should be equal to 0. That is one case. Okay, and now what does this mean, mask equal to 0? What does this mean? This means that fully even. So all numbers are coming even number of times. All 0 to 9, every number is coming even number of times with even frequency. Okay, and for L to R we have if map dot find mask. Okay, so we have to just find similar mask. We have just seen in the above question why and how and what, because odd minus odd is coming even, and all such we have learned. Okay, so this is also for fully even, but for L to R. Now what if, now palindrome can also be possible if there is one such number. Okay, maximum one such number whose frequency is odd. So while going into the loop, can we check how many set, or how many numbers have odd frequency? This is for 0 to I am telling. Okay, for 0 to I we have to do basic stuff. For 0 to I, whatever we do, we have to do very brute force approach kind of thing. Okay, so for 0 to I we will maintain, for the above question also, if you remember, we have made a frequency area of 5. So here we will made frequency area of 10, wherein we will store the frequency of all such 0 to 9 numbers. Fine, but here our odd frequency we will count that. Okay, how many odd frequency we will have, or we can count how many how many bits are set in mask. So if it is only 1, okay, so if the set count is only 1, then it's true. Okay, then we can calculate the answer. Okay, this is for what? This is for again 0 to I, but 1 odd frequency. Or I can say set count less than equal to 1 also, because for 0 also mask is equal to 0, or set count less than equal to 1. Here, does this mean that set count is 0? Number of bits I have set is 0? Yep, it's the same thing, right? But what is for L2R? What for L2R? Okay, what for L2R? See, this 32424 is okay. It's good. Okay, but what if I want this 24241? 24241. This is what I want. Then what we can do? So let's say, let me just show you by trying only. Let's say we will take this much array. 3 to 4 to 4. 0, 1, 2, 3, 4. So 0 to 4 index. Okay, our mask will be, I have already written. I'll just write this 0, 1, 0, 0, 0. Okay, here the numbers are until 5 only. So let me write until 5 only. 0, 1, 2, 3, 4, and 5. Okay, I'm not writing for until 10 digits. As here for the string, it's 5 only. So let's make it 5 only, shorter mask. Okay, now let's say I want to go to this part from 24241. So I want for this. Okay, so let's say what will be for 324241? What will be for this? The mask will be what? The mask will be for 5 it is 0, for 5 0, for 4 there are 2 counts, so it is even, so 0. For 3 it will be 1 count, so it will be 1. For 2 it will be 2 frequency, so it is even, so it is 0. For 1 it will be only 1, so it's 1 and then 0. So this is the mask I have got. Now if exact this mask I got anything anywhere earlier, this means that I've got number 3 any odd number of times before, and number 1 also any odd number of times before. So it's the same mask I've got, so I'll cancel it out. So now whatever I take between L to R, every number is even. But for this thing, what can I do? I need to find something which is just toggled by 1 bit. That means that this same mask, but it's okay if this one is 0, or it's okay if, oh sorry, if this one is 0. Okay, here I've made this one as 0, and here I've made this one as 0. I mean, you can toggle this bit also. So you can toggle 1 bit. You can toggle 1 bit. What does this mean by toggling 1 bit? This means that for 0 to R index, you have got the frequency of 3 as odd and frequency of 1 also as odd. If you will subtract something where frequency of 1 is odd, so now the frequency of 1 has become even from L to R, but the frequency of 3 is even only in that case also, from 0 to L minus 1 also. So frequency of 3 remained odd only in L to R, but that's okay, because we have toggled, it's okay to have at least 1 bit, at most 1 bit to be odd, at most one number to be odd with odd frequency. So what we need to do, one extra condition is, we can try to toggle at maximum 1 bit is possible. Okay, maximum 1 bit of toggling is possible. And now this could be this bit also. So what does this mean? If I've got from 0 to R this thing, okay, for 0 to R, this mask is for 0 to R. So if I've got for 0 to R this things, this is 3 number, and this is 1 number. So 1 number and 3 number has odd frequency. Now here also 1 number has odd frequency, 3 number has odd frequency. This is for 0 to L minus 1. So now for L to R, 1 and 3 will be of even frequency. But this is 5. This is what? 5. So 5 will be of odd frequency. Will that be valid? Okay, it's valid. Because rest all 4, 3, 2, 1, 0. Rest all are rest all are with even frequency only. Only one with odd frequency. So that's valid. So we need to toggle each and every bit of our mask. So we'll go into our mask, we'll toggle each and every bit and we will see. Now how to toggle and see, we will see in the code only. I have already shown you in the previous video of bit prerequisites. By doing XOR, we can toggle. Okay. If you have not watched, please go and watch out that video before watching this thing. It will be very helpful. Okay. Let's just quickly move to the code and see. Fine. So we will have this NSS dot size. We will store mask and what mask and I. Okay. We will have the answer also. Also what we want, frequency of each number. Correct. So vector of int frequency of 10 size. How we will store frequency of s of I minus 0, because this is string. So we have to store in numeric form. Okay. So s of I minus character 0, it will store according to the number. Okay. What we will check? What we will check? We'll create one mask. Okay. For int j is equal to 0, j less than 10, j plus plus. Int mask is equal to 0. If frequency of j modulo 2 is not equal to 0, that means it's odd. Then what we will do? We'll do mask is equal to mask or 1 left shift j. So we will set ith bit if it is odd. Okay. And also we will maintain one variable of set counts. I mean, how many bits we have made set. So whenever we are setting the bit, we will doing it plus plus. Clear? We will doing it plus plus. Now, let me write it separately only so that you can understand. So for 0 to I subarray, for fully even, what will be it if mask is equal to 0? So your answer will be maximum of answer comma I plus 1. Okay. And for L to R subarray, for fully even. Okay. For fully even, what will I check? If I can find the similar mask in my map, I'll just do I minus map of mask. Okay. What is this I minus map of mask? To understand this, you need to go from the video wherein I am understanding what is prefix sum subarray. Clear? Now, again, for 0 to I subarray, for one odd frequency. Okay. What will you check? That if set count is equal to 1, means there is just one odd, then also I can consider that to be palindrome. So I can make a palindrome out of it. And for L to R subarray, for one odd frequency. Now this is to watch it clearly. What we can do? We can toggle every bit. So we will go for j is equal to 0 to j less than 10. Our bit size is maximum of 10. We will toggle each and every bit. Now for toggling, we cannot toggle in the original mask. Okay, just be clear. So we'll create one new mask, which will be this mask, and jth bit is toggled, wherein jth bit is toggled. So if your mask is this 0000501111, okay, then and then for j is equal to 01234, j is equal to 4. So this bit will be toggled. So your new mask will be what? 5 zeros. Okay. And then this bit is again 0. So this will be your jth. For j is equal to 4, this will be your new mask. And we will now find it in the map if it is present or not, simply. So if we'll find it, we'll simply do I minus map of what? New mask. Clear? Now for adding, what we have to do, if it is not present at all in the map, so if, because this is maximum related, so it is, if our mask is not present, then add our mask for ith index. Okay, and let's just return the answer and check it out how it is working. Clear? Done. Okay, so with this approach we have learned the very hard questions of bit mask with subarraysum, and I hope you got it easily. Now you are able to solve it easily. You will get this two video in the with this two questions in the description, and also the notes of bit mask and whatever we have learned in the class in the description. So like, share and subscribe. Now we will move on to counting pairs using maps in the next video. Stay tuned, stay safe, bye bye.